We'll proceed in summation to integral discussion. Okay, summation to integral discussion that we are proceeding, and it is mind blowing and interesting. Okay, so it is mind blowing and interesting. What is interesting here is summation to integration. So, summation to integration, that is something that is mind blowing, interesting. Okay, so what we are seeing in the summation to integration is we are into phase of calculating the surface area of a sphere. Okay, and surface area of the sphere, we whatever we calculated dp by dx cross dp, I'm sorry, dp by dx cross dp by dy, and then modulus means magnitude delta x delta y. That is only for the top of the hemisphere, because it is x axis and y axis we have taken into consideration. Okay, so there are kind of dp by dx, dp by dy. When we talk about actually, okay, it is an explanation that why the surface area, if you watch previous video, why the surface area was coming as 2 pi a square rather than 4 pi a square. So we calculated the surface area. Okay, we calculated the surface area. We calculated the surface area. We calculated the surface area of a sphere. So we calculated the surface area of a sphere, where a sphere, half of the sphere is above the xy plane and half of the sphere is below the xy plane. Means this is centered at the origin. This is centered at the origin. If this is centered at the origin, from origin, if I take any point P here and draw a line, and that is position vector. Okay, this is what we saw. And then we draw any point on the sphere, any point on the sphere, it is centered at the origin. In that fashion, center of this sphere coincide with the origin 0, comma 0, comma 0. In that fashion, this plane, if I cut it, then top half is above the xy plane, and below half, top hemisphere and bottom hemisphere, and below is below the xy plane, above the xy plane and below the xy plane. If that is the case, then I take any point P here, and from the origin I draw a straight line. From origin I draw a straight line, that is called position vector. Now at any point here x comma y comma z, now I draw a line, I draw a circular line where y is constant in xz plane. Then here I draw a circular line where x is constant. If I take this circular line, then that circular line I divide it into n part, and this circular line I divide it to n part. Straightforward. Okay. This explanation is not there in any of the book. Getting the surface area of a sphere through repeated summation, and that to multivariable repeated summation, not only to repeated summation, multivariable repeated summation. Okay, in that fashion, if I have a, okay, I'm trying to again bring it to circular form so that it will be close. Okay, so it is circle again. Now this is the circle in XZ plane y constant. If there is sphere at point P, I draw a line point P and connecting back to point P where y is constant. And at point P on the sphere, I draw a line connecting point P back to point P where x is constant. This is the circle where y is constant, and this circle I divide into n sections. The circumference I divide into n sections. Now this is the x-axis, this is z-axis, where y is constant. Okay, in that fashion, if I take ith section where point P lies, you see the ith section where point P is lying. If point P is lying in ith section, then at that point we say if this is P and this is P1. Okay, what is P and what is P1? Okay, this is the x-axis, and this is the first section, second section, and ith section. So this is the ith section if I divide this into n parts. Now this is the first radius of the ith section and next radius of the ith section. If this is P and this is P1, what I'm trying to say here is that there is any point P here and P belongs to the ith section. Okay, at point P, consider point P falls in ith section. P is x comma y comma z. This is the ith section. This is the ith section. Consider this is point P. This is x comma y comma z. This is x-axis and this is z-axis. Y is constant. This is x comma y comma z. And another, if I move delta theta I, this is the section. This point is x1, y1, z1. Means if I talk about this position vector, then this is p position vector, this is p1 position vector. P1 minus P will be like this, tangential vector. Okay, I can also show P1 minus P is delta P, change in position vector delta P. Delta P, this is delta P. This vector is delta P. This vector is P, this vector is P1. P1 minus P, how much vector got changed? That is delta P. How much this vector got changed? Because there is change in x-axis. There is change in x-axis. Then it is delta P by delta x. Now if I take another circle where we are talking about the ith section again or jth section, I cut that circle into n part where x is constant. In that fashion, there also point P is there. P went on both sides. Point P is there, and that is x comma y comma z. Another point is x1 comma y1 comma z1. Mind it that x1 and x are same. In the first circle where y is constant, I said this point is x comma y comma z. Then another point is x1 comma y comma z. Y is not changing. Okay. What we are trying to say is if this is the sphere and center at the origin and this is the xy plane, if I take any point P here, then from P I draw a line that comes back to P, making sure that y is constant. This is x-axis, this is x-axis, this is y-axis, and this is z-axis. X-axis, y-axis, z-axis. Then any point P here, half of this sphere is above xy plane, half of the sphere is below xy plane. This is point P here. Point P, I draw a fictitious line that goes and come back to point P only, making sure y is constant everywhere on the line. At point P, again I make another circle and come back to point P, making sure x is constant out there. Now we have two circles. This is what I'm trying to say. This circle is where y is constant, and this circle I divide into n sections. Okay, if this is x-axis, then this is z-axis. This is the section number ith section. Now, if this is the ith section, out of n section, this angle is delta theta ith section delta theta I. This angle is theta from the x-axis. Consider this point is x comma y comma z. This is what we are talking point P. Then this is a new point P1, which is x1 comma y. If it is y, this is also y only. x1 comma y comma z1. Okay, in that fashion, if I say p1 minus p, how much p change, then it will be another vector that will go like this. P1 plus P2, then another vector will go from middle of this. That is the resultant vector of P1 plus P2. P1 minus P2 will go on vector like this. Tangentially, it will go like this. P1 minus P2. That is also we can call delta P. Delta P. So delta P, change in position vector, change in coordinate x comma y comma z to x1 comma y comma z1, when we have delta x change along x-axis. From this is x and this is x1, then there is a delta x change. Because of delta x change along x-axis, how much position vector change? Delta p by delta x. This talks about delta p by delta x, talks about how much position vector is changing. Position vector is changing with 1 unit of change in x-axis. If I multiply this with the with the how much I want change, I believe it is all right. Okay, what I'm trying to say, does anyone know that how much position vector is changing if there is 1 unit of change along x-axis? That is, if I know from here to here it is delta x, then it is delta p, how much it changed because of delta x movement. If I say delta p by delta x, then it is how much position vector change because of 1 unit change in x-axis, that is delta p by delta x. Delta p by delta x. How much position vector change because of delta x change, that is delta p. I believe it is all right. How much position vector change when there is delta x change along x-axis, then change is delta p. How much position vector change when there is 1 unit of change along the x-axis, then delta p by delta x. Both are different things. If there is change of delta x, then how much position vector is changing in delta p? If there is 1 unit of change along x-axis, then how much position vector is changing? Delta p by delta x. Delta p by delta x means per unit change along x-axis, how much position vector is changing. If I multiply it by any x interval, then it will give, if consider there is a one interval called here called delta alpha, from one x to another x, then how much position vector will change if I move x-axis from alpha 1 to alpha 2, delta alpha, then it will be delta p by delta x into delta alpha, because delta p by delta x is the 1 unit of change in the x-axis brings how many units of change in the position vector. Okay, what about delta xi, ith section? Then I have to multiply delta xi. If I say delta p by delta p by delta x is vector. If I calculate the magnitude of it, this is the actually change in position vector magnitude. I see 1 unit of magnitude, I see change in the x-axis. Multiplying it by delta x again will give the actual length of the change, considering this is a straight line. Okay, how much actual? So this is the actual length we are getting like this. What is the actual length? Delta p by delta x magnitude into delta xi. Ith section, what is the delta x? Similarly, in the other circle we are talking, the what is the change? What is the change I see when there is a delta y change, ith section or jth section? If I this is a circle in yz plane where x is constant, and I cut it into n part. I talking about jth section. So in jth section, how much position vector I see change? How much position vector means? Idea is to find the arc length. What is this arc length of the ith section? I believe it is all right. What is the arc length of the ith section? If I know arc length of the ith section, arc length of the jth section, this is the one circle where y is constant. This is another circle where x is constant. If I know this length and then I know this length, if I do multiplication of these two lengths, because they are more or less in perpendicular to each other, they are lying on perpendicular plane. They may not be perpendicular to each other, but they are lying on perpendicular plane. One is in xz plane and one is in yz plane. They are lying on a perpendicular plane. So if I do multiplication of this, I believe we have demonstrated it 2-3 times. So if if this is the position vector, then I'm talking about this circle which is where y is constant. I'm talking about this circle where x is constant. Here, if I say delta p by delta x into delta xi, ith section delta x, that is will give the length of this section when there is a movement of delta xi, ith section delta x movement. What is the length of the arc? Similarly, in this circle, delta p by delta y magnitude into delta y ith section will give the length in the ith section or jth section. If I multiply these two lengths, it will give the area around the p vector. It is created when there is a delta x change along x-axis and delta y change along the y-axis. Makes sense? Now delta x delta x now I have divided this circle into n parts. In that fashion, circle into n parts. Not this n, not this n is number of, I believe it is all right. So what I'm trying to say that this is x-axis and this is z-axis. This circle, this is y-axis and this is z-axis, where y is variable, here x is variable. Now I make radius like move like this, and I make end section chop. I did not made a chop like this end section. End section chop happened in angular fashion, whatever it is. Even it is angular fashion end chop I have made it. Okay, there will be chop on the x-axis also. May not be that all chop are of equal width, because chop happens in angular fashion. But one section I can describe as delta xi of the ith section, that is for sure. Delta xi means delta p by delta x magnitude into delta xi gives the ith section this length. Okay, another delta p by delta y magnitude delta yj in the jth section in this circle. Now at point P, now at point P, at point P, if I see this section and I see this section in xz plane and this section in yz plane, that I have considered as a straight line. If I take the delta P, it is a straight line. Considering delta theta is very small, delta theta I or delta theta j is very small. So considering it as a straight line, so this straight line and that straight line, if I multiply, then it should become area around P vector because of the ith section in x-axis and jth section along the y-axis. I believe it is all right. Okay, in this fashion, we have now we have delta p by delta p by delta x magnitude into delta xi of the ith section. Another delta p by delta y magnitude delta yi with delta yj of the jth section. Now if I add for all I and all j, then it gives the full area. This is the area of, if this is x-axis and this is y-axis. X-axis we have chopped it. We chopped the circle into n parts. We chop the circle into n parts and this circle into n parts. If I chop into n part, we chop the indirectly we chop the x-axis only. But all the width in the x-axis is not same. That is the problem. If I chop equally along x-axis, all width of the chop is same. But if I chop along the circumference n times, then on x-axis it will not be same. At the beginning it will be small. If this is if this is a circle and this is x-axis, if I chop the circumference equally into n section, the first one will be small on x-axis. Here it will be bigger. So it is different, whatever it is. For the ith section, consider this chopped here is delta xi. This is what I am saying, delta xi. Similarly, here in this circuit, jth section, the width is delta yi. Anyway, what is the area at point P? Area around it at point P when we see delta xi and delta yj. At that point, area is delta P by delta x magnitude into delta xi multiplied by delta P by delta y magnitude multiplied by delta yj. Summation of I equal to 1 to 1, summation of j equal to 1 to 1, and this explanation gives the full area of the sphere. This is what we are talking. Anyway, we have seen it. Now delta p by delta p by delta x. Okay, magnitude delta xi and delta p by delta y, magnitude delta yj. If I combine this, it becomes magnitude of delta p by delta x into delta p by delta y, magnitude delta xi delta yj. Delta p by delta x is a vector and delta p by delta y is a vector. Two vectors cannot be multiplied. Either they have to do dot product or cross product. In that of area, we are doing cross product. So it becomes delta dp by delta p by delta x cross product delta p by delta y, magnitude delta xi delta yj, summation of I equal to 1 to n, summation of j equal to 1 to n. Okay, please watch our previous video. This is a fit case to say that first is the magnitude delta p by delta x cross delta p by delta y, magnitude. It is function over x and y. If it is function over x and y and there is delta xi delta yj, that is similar to delta xi yj xy plane. If I consider xy plane as a one independent variable, and then fxy will become function over xy plane. So function over xy plane into delta xy, summation altogether I can take something that will be n square or something like that, because in on x axis we have n chop, on y axis we have n chop. So net area on xy plane will be n square only. Summation of something that will go 1 to n square, and then function over xy plane and delta xy. This is more or less a computation that is showing a volume kind of scenario, though it is not a volume kind of scenario where on the x-axis we have so many small area. Make sense? It is something like that. On x-axis, I have so many small area, so many small area. This is xy plane, this is x-axis, and this is y-axis. This is center, blue color. So there are so many area here, small area. One area width is delta xi, delta yj, that belongs to ith section on x-axis and jth section on y-axis. That area is delta xi delta yj. Okay, and then function over x and y, function over xy plane, that is magnitude dp by dx cross dp by dy, magnitude. This is showing something like a vertical. Okay, more or less it looks like we have calculating a volume where we have so many area. Okay, whatever it is. Now integration of when we calculate summation, where we have function over something multiplied by delta x, fx delta x, where it belongs to ith section, summation of I equal to 1 to n. It can be transformed into integral calculus fx dx, integration x equal to begin to end, not I equal to 1 to n. This can be transformed in that fashion. Here independent component is xy plane. Function over xy plane, that is dp by dx cross dp by dy magnitude into xy plane into delta of x, here delta of xy. Okay, in this fashion it typically forms like if this is x-axis and this is function over x-axis. If this is x-axis, this is function over x-axis. Height. In that fashion, fx dx means if this is fx dx is the area. Fx dx is the area, integration of fx dx. If I say fx into delta xi, this is area of one strip if I divide this section into n parts. So fx delta xi, if I sum all it, it gives the full area only. So it can be turned into integral calculus. That's why we came into integral calculus fxy, fxy plane into dxy. More or less it becomes integral of the in xy plane and in integral in xy plane. Integral in xy plane, and then fx is dp by dx plus dp by dy, magnitude d of xy, dx dy. Anyway, then we saw it came at 2 pi a square if we calculated. Because if we take x and y, if we take in x and y, we are computing it for the top hemisphere only. If I add for the bottom hemisphere, it will become double. So that's why it should be 4 pi a square. Anyway, the concept here is, looks like anyone would say, a concept of calculating the surface area of the ith section of the area is very concrete. Okay, can you proceed like in other coordinate system where I don't need to multiply by 2? For top, if I take Cartesian coordinate system, then whatever x and y we are talking, it is x axis, y axis, it is above the xy plane only. For below, I have to multiply by the 2. Okay, when we took the limit, please watch our previous video. When we took the limit came on the x-axis as a circular limit. Because if I have a sphere centered at the origin, then the intersection on xy plane is a circle. Only if it gets inside it, where bottom is below and top is above the xy plane, the intersection on xy plane will be a circle only. But whatever we computed for the circle, so we computed for the top half. For the bottom half, we have to multiply. No, 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 no. You do something where we don't need top half and bottom half. It should altogether give 4 pi a square. Anyone would say like this. It should give 4 pi a square. Okay, we will try. Let's try the polar coordinate system, the spherical coordinate system. What is a spherical coordinate system? What you said. I said that if I take any, this is centered at the origin. I take any point P here and I draw a circle so that x is y is constant. Then I draw a circle. I draw a circle where y is constant. Okay. Now hypothetical two circle I took. In the first circle, if I cut into n part, I take ith part. Then okay. Then if I take first circle, if I take first circle where x is constant and then I take the ith part, then here if I compute the change in P, because change in delta x, then it is dP by dx into delta xi, that is the delta x for the ith section. Then it gives me this vector, this vector. Then in another way, we get same thing by dP by dy into delta yj. We get this vector. At any point P, if I get both the vector, one is in this pen, one is in that pen, I do cross product, I get the area vector. That is the root of the concept. Or someone can think in other fashion that we have given already the proof. If this is the ith section and from this is the position vector P and P1 x comma y comma z, this is x1 comma y comma z1 because y is constant. In that fashion, this arc length is this delta x whole square plus delta y delta z whole square. This is xz plane. Delta y whole square plus delta z whole square root. This is the length of this arc. Someone can go this fundamental way also. In that fashion, we have in xz plane where y is constant, the arc length of the ith section is delta xi whole square plus delta zi whole square root. Similarly, that side it is delta yj whole square plus delta zk. Here delta xi whole square plus delta zi whole square. There delta yj whole square plus delta zj, j section whole square root. Okay, the first one, if I take the magnitude, it gives the arc length. Magnitude is this delta xi whole square plus delta zi whole square root. This is the magnitude of a vector, that is delta xi I vector plus delta zi k vector. Okay, where delta x is change in x and delta z is change in z. I can rewrite it as delta xi I vector plus delta yi j vector plus delta z I k vector. How you introduce delta y here? Because I know delta y is 0. There is no change in delta y. So 0 I can add. No problem. So I can say now the vector magnitude of the arc length of the ith section. The arc length of the ith section in this circle where x is y is constant, arc length is this length, that is delta x, and this length, that is delta z, whole whole square, Pythagoras theorem. So it becomes delta x I whole square plus delta z I whole square root. This is also can be said the magnitude of a vector, that is delta x I vector plus delta z ith section k vector. Magnitude of this vector is same thing. Okay, I can introduce here delta y I j vector also, because I know delta y change in y is 0. So 0 I can place in nicely. I knowing it is 0. Now it become magnitude of delta xi plus delta yj, delta xi vector plus delta yj vector plus delta zi section k vector. Magnitude of this is the arc length. Okay. Now if this is the magnitude of this, then I can take out delta here and it becomes xi plus yj plus zk. That is p vector. That is p vector. Delta of p vector magnitude. That's why I said if this is p and this is p1, the delta of p is this vector and its magnitude is the arc length. We brought through this fundamental also. Delta p magnitude where y is constant, that vector into delta p that side also. It will come to that side where if we introduce delta x there. The arc length is the jth section on this circle. This is the circle where x is constant. The arc length of the jth section is this is delta y and this is delta z. Jth section will be delta yj whole square plus delta zj jth section whole square root. This is the magnitude of a vector, that is delta y jth section j vector plus delta z jth section k vector. Now I can introduce delta x, considering delta x is 0 there. It becomes magnitude of delta x jth section I vector plus delta y jth section j vector plus delta y jth section k vector. Magnitude of this vector. If I take out delta, it becomes xi plus yj plus zk. It becomes delta p only. Delta p magnitude into delta p magnitude. Okay, this will give the our desired area. Okay, now I can bring in one magnitude of delta p into delta p. Delta p is a vector and delta p is a vector. Magnitude of these two, if two vector I cannot multiply. I have to do cross product. Delta p in the first circle cross delta p in the second circle will give the area. What we are talking, the area. Now delta p in the first section, that is variable with the delta x, and delta p in another section is variable with delta y. I can rewrite as delta p by delta x cross delta p by delta y. Okay, first is for ith section, delta p by delta xi cross delta p by delta yj jth section. Magnitude outside delta xi delta yj. This is the area of the I and jth section. Means summation I equal to 1 to n, summation j equal to 1 to n will give the full area. So this way of we brought the same thing. Okay, someone would say now, can you do in a spherical coordinate system? Little bit I'll talk here to give in a spherical coordinate system. What we got here? dp by dx change in position vector when we change the x. dp by dy change in position vector when we change y. Magnitude delta xi delta yj. Consider that in a spherical coordinate system, if I talk the surface area, then radius is constant. In a spherical coordinate system, if I talk about the surface area, then everywhere radius is constant. I can say A is the radius of this sphere. Because for surface area of a sphere, radius will not change. Phi, that is angle with the vertical. There are three independent components in a spherical coordinate system. Phi, that is angle with the vertical. Theta, that is the angle on the xy plane. Okay, so phi angle with the vertical and theta is the angle on the horizontal. If I talk about any point here P, then P is A is the radius, comma. For theta it is, for phi it is phi into A, that is the arc. I'm talking about This is not there in any of the book. How I can describe position vector in a spherical coordinate system? If consider this point as P, then what is P? X comma y comma z in Cartesian coordinate system. What is it is in a spherical coordinate system? P is radius. There are three independent components: radius, phi angle. That is, anyone can see the spherical coordinate system. Radius from center. This is one coordinate. One is from vertical. Vertical, how much angle it makes with the vertical. That is the phi. And horizontal, how much angle it makes on the horizontal axis. This is theta. These three are variable in the spherical coordinate system. So if I talk about any point P, then one coordinate is radius, another coordinate is this length, this, this length, because any point P can be described with the length only, not with the angle. So radius is a length, so no problem. What about this length? If this angle is phi, then radius into phi, that is this length, this arc length. If I talk about theta, theta arc length, then if this is the radius on the xy plane, then r into theta is the arc length till P. Makes sense? Consider, consider this is x-axis, this is x-axis, this is y-axis, this is z-axis. P is, this is x-axis, I rotate x-axis little bit, and P is at rotated point. Here the P is, how much it moved? It moved r theta, that much is the arc it moved. So for theta, the position is r into theta. For position in phi, radius moved this much to come to this stage, r into phi, and then radius. So radius comma r theta comma r phi. But someone you take radius here, you took like this, and for phi radius you take same radius. If I take same radius and this is the angle phi with the vertical, then r cos phi will come here. R sin phi will fall on xy plane, and then theta. Okay, in this fashion, any point P can be described in a spherical coordinate system as r, comma, r sin phi theta, how much theta it moved, comma, r phi, that is how much phi it moved. This is pure spherical coordinate system. R into r unit vector, like I, j and k is in Cartesian coordinate system. R into r unit vector plus r sin phi theta, theta unit vector plus r phi, phi unit vector. Okay, in that fashion, first thing we did was summation, the ith section summation. The ith section summation was delta p or dp by delta xi. Delta x and y we took as independent variable here that are changeable on the xy plane, and surface area is changing. Here the variable are theta and phi, theta angle and phi angle. If I take surface area, then theta angle is varying and phi angle is varying, where all around it radius is constant. So we will make it again as dp by dx cross dp by dy, where x and y were variable in Cartesian coordinate system. We will change it to dp by d theta cross dp by dr. Magnitude d theta dr. Earlier it was delta x delta y or dx dy. Okay, we will prove it, but directly we will come to this stage. And then integration of theta from one location full 2 pi and pi full pi. Pi, that is vertical angle, it will go full pi. Now it is dp by d theta cross dp by d phi. X and y change to theta and phi. They are variable here. R is constant. But make sure that if someone does dp by d theta, then phi is constant the way we did. dp by dx, then other variable y is constant. dp by dy, other variable x is constant. If I say dp by d theta, then other variable phi is constant. Cross dp by d phi, other variable theta is constant. Magnitude d theta dr, d theta d phi, and then limit. Will it give the surface? We will try. Okay, what is P? P is r unit vector plus r sine phi theta, theta unit vector plus r phi, phi unit vector by d theta, where phi is constant, r is anyway constant. So dr by d theta 0, because it is r is constant. R sine phi d theta by d theta, gone, theta unit vector will be there. R sine phi theta unit vector. d phi by d theta gone because phi is constant. It became r sine phi theta unit vector cross product with d p by d phi. Then dr by d phi 0 because r is constant. d of r d of r sine phi, that is right now it is constant. D theta by d phi will come. It is again 0 because theta is not dependent upon phi. Theta is constant here. It became r d phi by phi r phi unit vector. So it became cross product of r sine phi theta unit vector cross r phi unit vector. Theta and phi unit vector cross will give r unit vector. Means surface area vector is r unit. This is better than xy coordinate system where we are getting a surface area vector also. And surface there also we are getting surface area vector minus dz by dx minus dz by minus dz by dxi minus dz by dyj plus k. This was the surface area vector we received after doing cross product of dp by dx cross dp by dy. If, please watch our previous video. Here it will come as r sine phi. It is much simpler. R sine phi theta unit vector cross r phi unit vector. It will become r square sine phi r unit vector. Theta unit vector, phi unit vector cross will give r unit vector. I have changed dp by dx cross dp by dy magnitude dx dy into dp by d theta cross dp by d phi magnitude d theta d phi. Here independent variables are in theta and phi. There it was x and y. In dp by d theta phi is constant. dp by d phi theta is constant. What is p? Earlier p was xi plus yj plus zk. Here p is r unit vector plus r sine phi theta theta unit vector plus r phi phi unit vector. dp by d theta where r is constant because the surface area. Theta is phi is constant because I have to take phi constant. It becomes r sine phi r sine phi d theta by d theta theta unit vector. R sine phi theta unit vector. Cross product dp by d phi. First dr by d phi 0. R sine phi d theta by d phi 0. Theta we have taken constant. R dr phi r d phi by d phi 1. R phi unit vector. If I do cross product of r sine phi theta unit vector cross r phi unit vector, it will become r square sine phi r unit vector. So area will go along the radius vector. Area is perpendicular to the surface. Anyway, now its magnitude. So r unit vector will go away. R is constant, that is a square. So a square sine phi d phi d theta, where phi is 0 to pi and theta is 0 to 2 pi, will give the full surface area because we have taken full pi as full pi and theta. I believe so. If it is does not give, then big surprise. Anyway, a square I can keep outside, and phi I have sine phi I have to integrate with d phi. That becomes as minus cos phi. Minus cos phi 0 to pi. It will come as 2. Minus cos phi 0 to pi, it will come as 2. 2 I can keep outside. 2a square. D theta 0 to 2 pi. 2 pi. 4 pi a square is a surface. But we will proceed on this. That is it really that straightforward that I can change x to theta and y to phi and I get, okay, how it came, that we will see. This is certainly not there in any of the book. Anyone can try internet or book where we get the surface area through repeated summation, bringing it to integral calculus in pure spherical coordinates. Generally, people go like if someone see the spherical coordinate system, it will be r sine phi cos theta I vector plus r sine phi sine theta j vector plus r cos phi k vector, where r phi theta is there and I j k is there. This is hybrid model of a spherical coordinate system and Cartesian coordinate system. Mistake means wrongly written in the book that is a pure spherical coordinate. It's not pure spherical. Pure spherical coordinate system is r unit vector, r sine phi theta theta unit vector plus r phi unit vector. This is pure spherical coordinate system. And if it comes to pure spherical, we can change x and y. If we have really changed it straightforward, what is the logic behind it? That we will see. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone. +91 is the India country code. 948316061 is a telephone.